Hello all. Water is one of the three core elements that makes life possible for all species on planet Earth. So it serves us of utmost importance. Here, along the video, we are discussing some of the ways in which water is purified. Now, let's divide the video into three parts for the ease of explanation. The first one is potable water, then demineralization of water, and finally desalting or desalinization of seawater. Let's take a look at the first one. Now let's understand the process with the help of a flowchart. Obviously, the first step is the collecting of raw water. Then its storage. The raw water collected is subjected to storage for a particular amount of time. Its objective is to naturally sediment the impurities at a macro level. It also helps in destroying some viral bodies due to their inactivity. Then the water is chlorinized in order to remove algae and other microorganisms along with any coloring substances in water. The next process is aeration. Then atmospheric air is either passed or water is sprayed into air then collected for oxidizing ions like Fe2 plus or Mn2 plus. It also helps in eliminating free CO2 and H2S. The next process is coagulation. The chances of colloidal particles are high in impure water. So it's aggregated using alum, the most commonly used coagulant. The particles thus aggregated are called flocules and is also called a floc when it's in bulk. Then the floc is led to sediment under a vessel naturally with the help of gravity. After all this process, water is then passed through a porous medium commonly made of sand in order to filter out all the excess impurities. Even though all the macro particles may remove, there is still chances for microorganisms. So the water is disinfected using methods like chlorination, O3 treatment, ozone treatment, and UV sterilization. Finally, the water is stored and is supplied. Now let's take a look at demineralization of water. Demineralization is nothing but the removal of all ionic impurities present in water. Here we are using a method called ion exchange process by making use of ion exchange resins. Ion exchange resins are cross-linked long-chain organic polymers, micropores in nature, carrying exchangeable ions. For example, cholesterol. Here we can see an image of an ion exchange resin. Now let's understand how an ion exchange process takes place. Here we can see the schematic setup of an ion exchange process. The raw water is first passed through a container with cation exchange resin. Here the cations present in water such as Ca2 plus and Mg2 plus get exchanged for the abundant H plus ions in the resin. And also then the water is passed to the anion exchange column. Here the anions like Cl minus and SO4 minus will be exchanged with the hydroxyl ion. In this process, the H plus and OH minus ions get depleted and is refilled using acids in the cation exchange resin and alkalis in anion exchange resin. Dilute HCl and NaOH are some of the commonly used refilling elements. Even if the earth is sufficient with water, about 97% of the water is saline, that is seawater, and just less than 3% is available for drinking purposes. This is way too less to fulfill human needs. So, in several places, seawater or saline is treated into pure potable, that is drinkable water. There is three main methods used for desalting of seawater. The first is distillation, then electrodialysis, and finally RO or simply reverse osmosis. Now let's take a look at distillation. We all know the process of distillation. The seawater is heated using a heating coil and is subjected to vaporization. And then the vaporized water is condensed and collected separately with the help of the untreated water, which stays at about the same as room temperature. This also helps in warming the untreated water and thereby saving much more energy. The condensed water thus collected will be free of any impurities, mainly of microorganisms and any kind of salts. Next is electrodialysis. Seawater is fed to a large electrolytic cell divided by two ion selective semi-permeable membrane, and electrodes are fixed in the outer compartments, as shown in the figure. On applying electricity, the cations and anions move from the central compartment to the outer compartments in accordance to the electrode charge. In the progress of time, the water in the central compartments get purified. The last but not the least is the reverse osmosis. In this setup, a small amount of sample water and the saline water is kept in two chambers separated by a semi-permeable membrane made of cellulose or nylon. Then, a pressure just slightly greater than the osmotic pressure of the solution is applied to the solution. By saying solution, we mean the saline water. The water is then forced to permeate the semi-permeable membrane and enter the compartment with the fresh water, and thus it is also purified. A word of thanks. As we all know, or may not know, about 790 million people all around the world don't have enough water even to meet their daily needs. So let's recall the luck and so do the necessity of water conservation. Thank you.